So what we're going to be looking at here is basic acid and base concepts and equations that we utilize to perform calculations throughout acid and base questions. So the first thing to understand is the autoionization of water. Basically what we have here is in this situation, if you have a container with just water in it, one of the waters will act as an acid, the other will act as a base, and you'll subsequently end up with hydronium and hydroxide ions in solution. Now Kw is a constant that's associated with the concentrations of both the hydronium and hydroxide ion produced during this autoionization process. The value of Kw is dependent upon the temperature. So 1.0 times 10 to the negative 14th is the Kw value for the autoionization of water at 25 degrees C. So one may ask, how is this equation helpful? Well, this equation will allow us to figure out our hydronium or our hydroxide ion concentrations at that specific temperature. So how would we do a problem like this? Well, first, what we're going to do is we're going to look at what we've been given. So what they've told you here is to find the hydroxide ion concentration of a 3.0 times 10 to the negative 2 molar HCl solution. Okay, so what they're wanting us to solve for is the concentration of the hydroxide ion. Okay, so this is what our unknown is. Now, what did they give us? Well, they gave us the concentration of HCl. Okay, and we know that HCl, when it dissociates, because it's a strong acid, it will dissociate into H plus and Cl minus. Okay, so, and recall that your H plus is the same thing basically as H3O plus. Okay, it means essentially the same thing. So I know the concentration of HCl, and since HCl is a strong acid, it completely ionizes. So if I know the concentration of HCl, I subsequently know the concentration of my H plus ion. If I know the concentration of my H plus ion, I know the concentration of my hydronium ion. So I've been given the concentration of my hydronium ion. So what am I going to do? I'm going to plug this into the equation up here and subsequently solve for my hydroxide ion. So let's see, 3.0 times 10 to the negative second. Okay, OH minus, and 1 times 10 to the negative 14. All right, go ahead and isolate your hydroxide ion. Like such. Okay, do the math, plug this into your calculator. So the concentration of your hydroxide ion is going to be 3.3 times 10 to the negative 13. So we know what our concentration is of our hydroxide by utilizing our understanding of our HCl and the fact that it's a strong acid and how it behaves in solution, as well as the Kw equation seen above. So overall, what you're going to make sure that you're paying attention to is what you've been given, and of course, what you are solving for, just like any other problem that you've done in the past. Now this brings us to the pH scale. So basically the pH scale represents the amount of H plus or H3O plus in solution. So basically, in order to calculate pH, we take the negative log of our H3O plus or H plus ion, and that gives us this nice scale that you see here. So the scale that you see here basically goes from 0 to 14, at least in the simple approach. What you need to understand is that when your pH is greater than 7, you are basic. Okay, and when your pH is less than 7, you're acidic. If you are exactly at 7, your solution is neutral. So basically, this is a pH scale. Let's go ahead and let's look at how we can utilize this to figure out other information. So some basic acid and base equations. So we've looked at the pH. To calculate pOH, all you do is take the negative log of your hydroxide ion concentration. And pH and pOH are related by this equation. So pH plus pOH is always going to give you 14 for a specific solution. And if you know the pH or the pOH, you can subsequently take the anti-log of that pH value And you can solve for your H3O plus or your OH minus. So in a very simple approach, if I want to know H3O plus concentration in solution, I just take 10 to the negative pH value that I have, and I can solve that. Same thing goes for hydroxide ion. The difference is that you'll use the negative pOH. So let's go ahead and let's do some more practice. Okay, so what is the pH of a 0.05 molar HNO3 solution? Okay, so once again, HNO3 is a strong acid. Okay, you're going to have H plus NO3 minus. All right, so we know the concentration of HNO3, so we subsequently know the concentration of H plus. So H plus concentration, or remember H3O plus, same thing, is equal to 0.050. Now, what are they wanting us to solve for? They're wanting us to solve for pH. So which one of these equations allows us to use H3O plus to solve for pH? Well, this equation is what's going to be used. So what we do is pH is going to be equal to the negative log of 0.050. Okay, and you're going to plug that into your calculator. And your pH is subsequently going to be 1.3. So you have an acidic solution here, which makes sense because your pH is below 7, and of course the fact that you have an HNO3 solution, which is an acid. Let's do this example here. So ask, what is the concentration of H3O plus in an HBr solution that has a pOH of 9.6? So they're wanting us to figure out our H3O plus concentration. Okay, and they've given us pOH. Okay, so they've given us a pOH of 9.6, and they want us to get to H3O plus. Now, there's no equation here that allows us to go from pOH directly to H3O plus. Okay, because pOH here is related to OH minus, H3O plus here is related to pH. So what we first need to do is we need to get out of pOH and get into pH, because pH and H3O plus are related. So we're going to utilize this equation here in order to figure out what our H3O plus ion is. So what we're going to go ahead and do is we're going to do pH plus 9.6, which is our pOH. That's going to equal 14. Okay, so pH is going to be equal to 14 minus 9.6, and that's going to give us a pH of 4.4. Now, pH is not going to, be necessarily directly convertible from the first several equations. But if we go ahead and we look at the anti-log equations here, we could subsequently figure out our H3O plus concentration. So in order to get H3O plus, we're going to do 10 to the negative 4.4, and that's going to give us 4.0 times 10 to the negative 5th. Okay, so this is our concentration of H3O plus in this HBr solution. As with any of these types of calculations, you want to look at what you're given, what you're solving for, and what equations or which combo of equations will allow you to get to the appropriate item that you're solving for.